I'm going to record this actually and post it to my YouTube channel afterwards for those that are unable to make it. It looks like we've got at least 2 viewers now. So again, if you've got some questions, go ahead and just type them in the chat window. Um, if you don't, that's fine. I will throw some questions your way and we'll just go from there. Um, I think for right now, the easiest thing to review is probably systems of equations. So let's review substitution and elimination, and we'll go from there. And then I did get one question via email earlier that I'll try to address too. Again, I'm going to be posting this to YouTube later too, so if you can't stay for the whole thing or anything like that, that's fine. We'll get it figured out. So I'm going to put a substitution and an elimination problem on this piece of paper in front of me, and then I'll have you guys try to do them both, and then we'll just kind of go from there and see what's what. So the first problem I'm putting on here is a elimination problem, so if you can follow along as I talk, that would be helpful, but I'm going to show it to you too. So the first problem would be 3x plus 2y equals 9 for the first equation, and 4x plus 3y equals 13. So that's going to be our elimination problem. 3x plus 2y equals 9, and 4x plus 3y equals 13. Solve that one with elimination. I'm going to get a substitution problem up here as well. We'll go with 3x minus y equals negative 1, and 2x plus 3y equals 14. Okay, so there's a substitution and an elimination problem. The top one with elimination, the bottom one do with substitution, and we'll just kind of go from there. All right, I'm going to do my work on here. And with elimination, you guys may end up having, something a little bit different than I do. That's totally acceptable. Oh, doing math in my head is sometimes tricky. Ooh, this one's going to turn out really nice. Wow, great. So I'm almost done with the elimination problem. And again, if you have specific things you want to see addressed, that's totally fine. I'm actually going to pull up my email. I did have a question via email earlier this evening, and I'm going to try to address that in case I don't remember who asked it. I think it was Monacy actually had asked me a question via email. So I'm going to try to address that. Just so I'm addressing that and getting it. It's easier to address these things in video form. So there's my elimination one. You should have gotten x equals 1 and y equals 3. So zooming in as close as I can there. This is kind of tricky to do. So I multiplied the top one by 3 and the bottom one by negative 2. This worked out pretty well because then when I added everything together, I just got a regular old x, and I got x equals 1. Then you plug that back into any of the equations, and it doesn't matter if it's the first one or the second one, and you should get y equals 3. And we can kind of confirm this answer by plugging it. We use the first one to kind of help us out, to help us find y, but if we plug it in the second one, we see that 4 times 1 plus 3 times 3 does get us 13. So that seems to work out pretty well. Then for the second one, I'm going to solve that with elimination. Or solve that one with second one. I'm going to solve a substitution. Excuse me. Gosh, I'm just all over the place. I'm almost done doing that. The biggest mistake people make on the substitution ones is either forgetting parentheses when they substitute in. That's a possible problem. The other one that I often see frequently as errors on the substitution one is, what was the other thing I was thinking of? Oh yes, they substitute back into the same equation that they started with. That's not going to help. You have to solve for a variable in one, and then plug into the other one. So for the second one, you should have gotten x equals 1 and y equals 4. X equals 1 and y equals 4. So there's my work. So I solved for y in the first one. I actually added y to the other side and then added the 1 back on. You could have just as easily subtracted 3x and then divided or multiplied everything by -1. But either way, you should get y equals 3x plus 1. I plugged that into the second equation. Solve for x, and I got 1. Plugging that back in, we get y equals 4. So I'm getting a couple of questions here. Jose asked, how do you do the no unique solution problems for 3 equations with elimination worksheet? Don't really worry about that, okay? All of your elimination ones will have a solution. So don't, if you see any of those on your 3x3 review worksheet, don't worry about that, okay? As long as you can do the ones that have solutions, you're totally fine. Will asked if we could go over 3x3s. Oh boy, those are definitely tough ones to go over in this perspective because we could all have very different work. But I think I can do it. Okay, so let's do a 3x3. I will read the work that I am doing on this as I do it. Okay, so I'm going to read the problem as I'm writing it, and then I'll also show it too. So no worries if you can't keep up right away. First equation will be 3x plus 2y minus 4z equals 7. Second equation will be 2x plus 4y minus 3z equals also 7. Yep. And then let's go with negative 5x plus 3y plus z equals, oh, that one's going to be negative 11. I'm hoping I did that quick math right in my head, okay? So there's the 3x3 problem we'll do, okay? And if you want to, here's the key, if you want to do it the same way as me, I'm going to be eliminating z's, okay? So I'm going to eliminate z's using the first one and the third one and the second one and the third one. So if you want to do it the exact same way as me, I'm going to use the first and the third and the second and the third, and I'm going to be eliminating z's the first 2 times, okay? So that should give you about the same work as me, okay? Really quickly, sorry, I got to shift my computer here. My battery's running out. Oh, sorry about that. Thought I had my computer charged. Apparently I didn't. Looking at some questions. Yeah, so Mia asked about finding the x-intercept. Is that just putting y at 0? Yeah, totally it is. Really, you just substitute in 0 for the intercept you're not looking for. So for x-intercepts, you change y to 0 and figure out what x is. For y-intercepts, you plug in 0 for x and figure out what y is, okay? Indepoy just asked, can slope-intercept form have a negative y? No. Slope-intercept form must have a positive y, okay? But, like, if for some reason you had, like, hang on a second, I'm going to pull off that 3x3 so I don't mess that up too badly. But if you had something like negative y equals 2/3 x plus 1, okay, this is not slope-intercept form because it's got a negative y. But you could divide everything by negative 1, and you get y equals negative 2/3 x minus 1. That's a terrible x. Wow, is that bad? But then now it's totally in slope-intercept form just by dividing everything by negative 1. She also asked, could slope-intercept form be y equals b minus mx or b plus mx? Basically, could the mx and the b be in the other order? Sure. Absolutely, it could. And Stuart, I'm not ignoring you. I'm just trying to get some questions answered. I'm only on for half an hour, but thanks to Stuart Lerner for stopping by tonight. Apparently, he must be still. Um, there must be someone with Ustream that's letting him know when I'm on, apparently. So, hi, Stewie. Yeah, so Aiden's questions, hopefully I answered those. But again, you know what? On your test, you're just going to see stuff written in the normal slope intercept form. Okay, I'm going to quickly do my work on the 3x3. I may do a little bit. You'll have to be patient with me. In order for us to get done relatively expediently, I may not show every single last detail of my work. Okay, so right now I'm working I'm working the first and the third and the second and the third, and I'm always getting rid of z's. Okay, because I see that plus z in the last one, and I figure, how bad could that really be? Okay, then I got to use the second and the third. And it also, I always like opportunities to only multiply one of the equations by something, because it'll typically keep the number smaller. But in this case, it's actually not looking like that might be the case. So I don't know. What am I multiplying that last one by? 3 now? Okay. Plus, I didn't have to multiply by a negative. There were a couple reasons I chose that, but in reality, you can eliminate any that you want as long as you are consistently eliminating the same one. Okay, so if you're doing this the same way as me, the two equations you should come up with are negative 17x plus 14y equals negative 37, and negative 13x plus also 13y equals negative 26. Okay, so those are the two equations I end up coming up with. I think I chose wrong here. These look terrible. But unfortunately, there is just no going back now. The problem is I ended up with a lot of prime numbers, so there's really going to be no great way to do this. So I'm just going to line them up. I'm going to write that negative 17 x1 right below the other one. And I'm actually going to have to use the calculator on my phone for this. I'm really hoping that I've got enough battery on my phone to use the calculator, okay? I totally do. So I'm going to get rid of... I'm going to get rid of y's now, I guess. So I'm going to multiply the top equation by 14 and the bottom equation by negative 13. That's always a safe way to eliminate numbers, is just kind of flip two of the coefficients on the variables and multiply by that, if that makes sense. So it looks like I'm going to be doing 13 times 14 a couple times here. So I get negative 322x plus 322y equals, and I got to do 26 and 14. That's going to be negative 364. Now I got to do 13 times 17. I mean, I could try to do some of this math in my head, but boy, it's just not worth it. Oh, and I'm multiplying by a negative, so I got to keep that in mind. Don't mind me, I'm just talking to myself a little bit. Helps pass the time. Otherwise, it's just kind of me sitting here awkwardly silent and you guys waiting for me to show you stuff. That's why it's really hard to do these 3x3s over the over Ustream like this, but we'll do the best we can. Just finishing up here, 37 times 13 is 481. Holy cow. Okay. So I end up with negative 322x plus 322y equals negative 364. And then I end up with 221x minus 182y equals 481. Hopefully I didn't screw any of the math up here. I have a terrible thought that I did, but we shall find out. I know I did something wrong, because 14... What is 14 times 13? Did I do that wrong? I think I typed something wrong into my calculator. Yeah, both those top ones should have been 182. Sorry about that. Wow, that's really bad math. 182, 182. See, at least I notice these things as I go along. Let me make sure I did the other one right then, too. Okay. Top equation should be good now, I think. So it should be negative 182x plus 182y equals negative 364. And then the second equation should be 221x minus 182y equals 481. If I add these together, I've got, let's see, so negative 182 plus 221 gets me 39x. And then I've got 481 plus negative 364. That's 117. Divide by 39. I think there's a chance I did this right. Yeah, sure enough. X equals 3 is what I get there. Okay. And now I'm just going to start plugging back in. This is actually the easy part now. So I plug back in. I'm going to plug back into that one with the 213. So I get negative 13 times 3 plus 13y equals negative 26. I end up, I'm not going to show every single step here. I get 13y equals 13. I get y equals 1. And then if I plug all the way back into one of the original equations, I'm also going to end up getting z equals 1. Okay? So, you know, sometimes you make some bad choices. And again, I almost made a huge mistake here. I must have typed something wrong into my calculator when I did 13 times 14. I should have known right off the bat that in the 300s didn't make any sense. Because 15 times 15 is 225, so why would I get something in the 300s for two numbers smaller than that? That doesn't make sense. Really, if you need help with any of the 3x3s, please let me know. You know, maybe stop and see me in at recess tomorrow. That might be the better way of dealing with things. Or quick before school, 8 o'clock. Just come to my room. I can quickly walk you through 3x3s if you're having trouble. This is really hard to do online, but it's the best I can do. I will post this to YouTube afterwards, so if you kind of want to walk through this a little slower, you could probably rewatch, and that would help. So I'm going to look at some of these questions now. So, holy cow. Oh boy. Oh boy. Oh boy. Oh boy. Aiden asks, 5A in the textbook shows all graphs with decimals. No, I'm not big into. I'm not going to make you graph like decimals on your graph or anything like that. So don't worry about that. You know, even the ones where you're making the table, like, I mean, you can use fractions in there if you really want to. I wouldn't recommend it, and you should be able to deal without it. Let's see. Jose asked, for the solve systems of equations by graphing, if the lines meet in the middle of the box. Oh, yeah. So if they meet in the middle of a box, obviously you're just making your best guess. That's all you can really do in that situation. Like, you know, so if you say it meets at 1.5 and 2 1/3, and it was supposed to be 1.5 and 2 1/2, that's okay. It doesn't matter what it was actually supposed to be, as long as your guess makes sense. Okay, so for example, I'm going to kind of talk about that for a second, because that's a great question. Okay, so I'm going to make some dashed lines on here, so hopefully what I'm about to do will not be too terribly confusing. Let's have them cross like right there. Okay. So do you see what I'm getting at here? If your lines cross there, it's crossing somewhere between x equals 0 and x equals 1. If you said x equals 1/2, that's fine. If you said x equals 2/3, that's fine. 3/4 is fine. I'd say 1/4 is, I should take off a point for that. But, you know, it just kind of depends on exactly where you see them crossing. Now, your y crosses somewhere between 1 and 2. If you said y was 1/2, well, that doesn't make sense, because that would be down somewhere in here. But if you said y was 1.5, you know, I mean, that's probably totally fine, so I wouldn't worry about that. Yeah, and it doesn't matter what it's actually supposed to be. So if it crosses in the middle of a box, you know, just make your best guess. Mia asked, if I solve for x and y intercepts and my answers are 6 and 8, do I just plot and connect them? Yeah. If your x-intercept is 6, go to 6 on the x-axis, make a dot. Go to 8 on the y-axis for the y-intercept, make a dot, connect them with a line. That's it. Nope, you don't need to do more for those specifically. Aiden asked, if you plot point slope form, would you plot the negative y or a positive y, because you put a positive y with a subtraction? So let's just... I'm not 100% sure what that question's asking, and she can't clarify, because by the time she clarifies, I will have moved on to something else, because there's a little bit of a delay here. So let's just be smart about this and write something in point slope form, and just go from there. So if you had this in point slope form, the point that you would be graphing first and where you would want to start your graph, again, you're trying to think of the x and y value that make both sides 0 because that makes the equation true. It's the easy way to make the equation true. Again, if that logic doesn't make sense, just do the opposite of x and the opposite of y. That's fine too. Okay, so the point you'd be plotting is 4 and -3. Okay, and that's a single point. It's not two separate points, it's one point. Okay, so it's 4 for the x and -3, again, the opposite, for the y. Okay, and then you'd go from there, you'd go up 1 over 2 because that was the slope. Okay, I got 4 new messages. Holy cow. Okay. Okay. So let's do, I'm seeing some questions on horizontal and vertical. Okay. Horizontal and vertical, these are the things that always seem to cause problems. So, okay. Let's just do this way. There's two things you should be able to do with this. You should be able to graph a horizontal and a vertical line, and you should also be able to write the equation of a horizontal and vertical line. Okay? I don't know how I best want to address this. So I guess, look, if it... Let's just do this. Okay, I got a blank graph here. Let's say you've got a graph that goes through the point 1, 2, and you know it is, let's go vertical. Okay, so that we're going to try to write an equation, but I'm going to actually physically show what this looks like on a graph, so you can kind of get, so I can kind of maybe kill two birds with one stone here. We'll see if this idea works. I don't know. Okay, but if I gave you that information and said write the equation of that line, that it goes through 1, 2, and it's vertical, let's just look at what that would look like. So the point 1, 2 is right there. It's right where I made that little dot. I didn't make, I'm not making a bunch of grid lines here. I'm making little hashes. Okay, if it's vertical, okay, the line is going to go straight up and down. Okay, I'm going to label that point 1, 2 so we don't forget where it is. That's what it would look like, correct? I think we're all okay with that going through 1, 2 and it being vertical. Look, if you just put some other points on there, just label some other points on that line because they're easy to label. The point 1, 1 is right below it. The point 1, 0 is also on there. If I go down a couple, I can get to the point 1, -2. What do you notice about all those points? I'll zoom in as much as I can. When I say zoom in, I mean hold the piece of paper up to the camera. What do you notice about all those points? Hopefully what you're saying to yourself is they all have an x value of 1. So x equals 1 is the equation of a vertical line that goes through 1, 2. I could go through the same thing with horizontal. Horizontal is going to be y equals 2, because if it goes through 1, 2 and it's horizontal, it's going to stay at that exact same height. The height is described by the y value, and the y value is 2 for the point 1, 2. So again, if you want to make your life, I get that logic. That logic makes sense to me. If that logic doesn't make sense to you, here's how you make your life easy. If you see x equals a number, that is always going to be the equation of a vertical line. Okay? If you see y equals a number, that is always going to be the equation of a horizontal line. Memorize that. Okay? So then if you see something like, if I'm telling you to graph x equals 2, you'll know that it's got to be a vertical line, and it's got to go through x equals 2. And if you know the difference between x-axis and y-axis, you should be able to handle that. If you see something like goes through the point -1, -2, and it's vertical, well, you know it needs to be x equals a number, and the only number it can be is, well, it's got to have this x value. X values come first in my ordered pairs, so it's got to be x equals -1. I mean, that's about the best explanation I can give there. If that hasn't made any sense, maybe come talk to me before school tomorrow, because that's about as much as we can do on horizontal and vertical lines over that. Okay. Couple other questions that are coming up. Can you use decimals for 6.5a, or do we have to use fractions? So if your line crosses in the middle of a box, you can use decimals or fractions, whatever you're most comfortable with. That's totally fine. Steph Goris asked, writing the equations, if it is y-intercept of 5 and slope of 2, that means you're doing slope-intercept. And if it, yeah. So if you're given the slope and the y-intercept, use slope-intercept form. For pretty much everything else, you're going to use point-slope form. Because for most of the other ones, you're either given a point and the slope, in which case you can just go straight to it, or you're given the point and you're given some other information that'll give you the slope, and that'll help. Will Robinson asked, will we have to do stuff in tables? Yes, you will have 2 graphs where you have to graph by making a table. So you'll definitely have to do tables there, and you'll need to get at least 3 points. Exact same thing as your concept quiz on that one. And you may also need to use tables when you're graphing, when you're solving the system of equations by graphing, although I guess that's your choice. If you can graph the lines in a different way, fine. In 6D, how would we know what to say, the value of y or x? Blakely, I don't have that review assignment sitting in front of me, so unfortunately I can't answer that question. Steph Goris then asked if it contains, like if you're given information about 2 points, like contains 4, 5, and contains 6, 12, is that point slope? Yes, you would use point slope for that one. Do we need to know perpendicular and parallel? Yes, so that's like a fancy way that I could give you slope. So basically, here, I'm going to write the same problem 2 different ways. And hopefully this will be a decent enough explanation. So one problem might be it goes through 1, 2 and has a slope of 3/4. Okay, that's one problem. I'm going to write down what the answer would be if I'm writing the equation because, hey, let's try to review as much stuff as possible in the next 3 minutes. Okay, so there's that. That's what the answer would be. Now I'm going to write the exact same problem in a different way. Goes through the point 1, 2 and is perpendicular to y equals -4/3 x plus, doesn't really matter, 5. This is really the exact same problem, and I'm hoping you see why. Perpendicular lines have what we call opposite reciprocal slopes. So you would flip the fraction, okay, so switch your top and your bottom, and you would change the sign on it. The slope of the line I said it was perpendicular to had a slope of -4/3. Flip that and change the sign, and you get 3/4. This whole thing, that whole disgusting mess right there, is just a fancy way of saying slope is 3/4. It's the exact same problem as the one above, and it would have the exact same answer. Parallel lines have the same slope. So yes, you do need to know parallel and perpendicular. But if you see that, all I'm really doing is giving you the slope so you can use point slope form in a very fancy way. Okay. Okay. You told us, okay, so I just talked about I just talked about parallel and perpendicular. Steph asked in 658 would use the table to figure out which. Yes, you would probably going to use a table for solving systems with graphing. And yes, when you are solving the system with graphing, the answer is where the lines meet. Make sure you draw both lines, circle where they meet, but then you still have to tell me x equals 1, y equals 2, or just write it as an ordered pair like 1, 2. Blakely found the problem. Oh, we're still asking questions on vertical and horizontal. So the problem that Blakely is interested in, if the line is vertical and contains 4, 6, how would you know what to say, the value of y or the value of x? I refer you back to what we just talked about vertical and horizontal lines. Vertical lines are always x equals a number. So you'd write x equals, and then you would pick the number in your ordered pair that represents the x value. X values come first in ordered pairs, so you would pick 4. So if the problem was vertical and contains 4, 6, your answer would be x equals 4. Okay, Bennett asked, how would I know the slope of a perpendicular line? I'm hoping that's just due to the delay that he didn't see that yet. If not, rewind. It's opposite reciprocal slopes. Opposite reciprocal slopes. I just talked about it. If not, I'm going to post this to YouTube in a few minutes, and you can rewind and watch that part. Okay. It is 8:30. So if you guys have additional questions, you can shoot them to me via email. I'll try to get to those throughout the night. But the easiest thing at this point would, hopefully, you don't have too many. Stop in at 8 o'clock tomorrow morning in 15 minutes with you one-on-one. I'm sure we can clear everything up. You can stop in at recess tomorrow too. I'll be around. I'll be in my room, and we can do some last-minute review then. So hopefully this was helpful. I will post this to YouTube too in case there's any specific things you just kind of wanted to rewatch and maybe watch slower or things like that. So that's it, and hope this was helpful.